All right, welcome to the practice math video. We're going to do some practice problems from the homework, and you can say hello to my cat, October. She will probably fall asleep during this video. Don't get any ideas. All right, so let us go on with this first one. What is the slope of the line through the point 39 and xy for this function, this parabola, and various values of x? What happens to the last slope when h is very small? Sketch, all right, lots of things to do. So first, we need to find the slope of the line. And that's going to be the second y value minus the first y value, the second x value, minus the first x value. Now the first x is always 3, the first y is always 9. And then we have to find for various x's what's going to be the case. So let's start with our first case. Let's say x is equal to 2.97. What is y going to be? Well, y is x squared. Okay. So y is x squared. So let's go to our, what's 2.97 squared? Go to our calculator, 8.8209. And we can find our first slope. It'll be 8.8209 minus 9 over 2.97 minus 3. We'll type that into a calculator. And let's see. This minus 9 divided by 2.97 minus 3. We're going to get 5.97. We'll also find two other slopes, right? When x, the next one, when x is 3.001. What is y in that case? Well, again, it's just going to be 3.001 squared. Why? Because y is just whatever the x value is squared. That'll be 9.006001. And then again, we'll just plug it into the formula and use a calculator. And we'll find that our second slope is something. .001. All right. Now, right off the bat, right, this is our first answer. This is our second answer, and this is how you should model your homework or your paper homework. Well, if x is a little smaller than 3, the average slope is 5.97. If x is a little bigger than 3, the average slope is 6.001, a little bit more than 6. So what do you think the slope is at 3? What's a natural guess to make? To the left, it's a little under 6. To the right, it's a little above 6. So maybe we think the actual slope at 3 is 6. Maybe. So let's do the last one. When x is 3 plus some small number h. So if x is 3 plus some small number h, what is y going to be? 3 plus that small number h squared. All right, so let's simplify. What does it mean for something to be squared? It means multiply by itself. We're going to have to FOIL. First, outer, inner, last. 3 times 3 is 6. 3 times h is 3h. H times 3 is also 3h. And h times h is h squared. Collect like terms, we get 9 plus 6h plus h squared. Okay. So what is our slope now? It's 9 plus 6h plus h squared minus 9, right? We always have that minus 9 on top. We always have that minus 3 on the bottom. Minus the x value. What was the x value? It was 3 plus h. How does this simplify? Very nicely. On the top, we have a +9 and a -9. Those cancel each other out. All that's left on the top is 6h plus h squared. On the bottom, we have a +3 and a -3. Those cancel out. All that's left in the bottom is h. Now, whenever we simplify fractions, we can only simplify fractions if they have the same factor. So let's do some factoring. We can factor an h out of the top. We're left with 6 plus h. If you're ever unsure about factoring, you can check your answer by distributing. If you distribute, you should get back to here. The denominator is just h. Oh, look, they both have a factor of h. So if the top and the bottom of a fraction ever have the same factor, they cancel and they get replaced by 1s. So we have 1 times 6 plus h. We don't need to write that 1. Divided by 1. And whenever we divide by 1, that doesn't change the fraction. This is our slope. So the average slope between when x is 3 and any x plus some small number h is just going to be 6 plus that value of h. Well, notice what do we have here? This is 3 plus a small number h. And look at the slope. This is like our value of h. The slope is just 6 plus that h, right? 6 plus 0.001 was our slope here. This up here, this is 3 plus some negative 0.03. That's some small number h. And what is this? That is 6 plus the h. It's 6 minus 0.03. Oh, you can see we found the slope of any secant line between that where one of the points is when x is 3 and the other point is some other thing on this function. This is going to be very useful when we calculate derivatives. I mean, whatever derivatives might be. It'll be useful later. I don't want to say the D word this early. Okay? So that's what we're doing here. What happens to this last slope when h is very small? When h is very small, the slope is basically 6. That's it. And last but not least, sketch the graph of this parabola for x near 3. You can do this on Desmos. You don't have to graph by hand in this class. All right, so y equals x squared. And we want to look very close to where x is 3. And if you look very close to where x is 3, you can see that this slope kind of looks like it's 6. If you get really close, if you really zoom in, the function gets kind of flat. And the slope of that flat is 3. All right. There we go. That's the problem. That's how you do this first homework problem. All right, so we'll just make a little note for the last one. Graphed on Desmos. All right, we'll check our answers. We'll put check marks next to every part that we got right. Yeah, we got the whole problem right. Great. I will provide the answers for you for these. So of course, right now I'm checking the answers against the answer I just did, but you will have an actual document, of course, that you can check your answers on. All right, there we go. Let's do another homework problem. This graph shows the distance of a car from some measuring position located on the edge of a straight road. All right, so there's a straight road. There's some measuring position at the edge of that straight road. So I don't know, maybe we have a road that looks like this. And then at the edge of the straight road is some measuring position. We're finding the distance of a car to that point at any given time. Then that's a car. Kind of looks like a skateboard or a banana with wheels. I don't know. All right. So we can see how far they are at any time using this graph. What was the average velocity of the car from between 0 and 20 seconds? 20 seconds, the car was here. 0, the car was here. The average velocity is just going to be the slope of the secant line connecting these 2 points. Really, if we really want to do this problem correctly, it'd be on the middle of some straight road, I think, but really, there's actually a lot of problems with this problem, but I'm not going to go into them. Let's just do what it wants us to do. Gosh. All right. So what was the average velocity? Well, remember that the average velocity, sometimes written as v bar, is just going to be the change in position divided by the change in time. What's our position here? This is after 20 seconds, distance of 300 feet, 0 seconds, and distance of 0 feet. So we are starting right on top somehow of this measuring device. All right. So again, the change in position was 300. The change in time was 20. We'll get 15 feet per second. We know it's in feet per second because y is in feet, x is in seconds, and its slope, rise over run, feet over second. And then B, what was the average velocity from 10 to 30? Well, at 10, we're right here. At 30 seconds, we're right here. So this average velocity would be the slope of this secant line, which should be negative. This is the point 10, 200, the point 30, 100. So again, we do the same thing. Change of position over change in time. Second minus first is the change. You have to be a little careful not to do too many of these in your head. It's easy to mess up the negatives. And we'll get -5 feet per second. So in the first 20 seconds, the distance is growing by about 15 feet every second. Between 10 and 30 seconds, the distance is actually shrinking by about 5 every second. Even though it grew for a little bit and then shrunk faster. On average, that's the slope of the secant line. Finally, letter C, how fast was the car traveling at these 3 points? How fast was the car traveling at this point? At this point. At this point. So remember, instantaneous velocity is all about slopes of tangent lines. If we had secant lines get really, really close, the points of secant lines get really, really close to each other. So what do we think the slope is right here? Maybe it looks kind of like this. What do you think this slope is? Well, we can approximate it by rise over run. Right, this is 5, so this run is 5, and it goes up 100. Rise over run, we think the car was probably going about 20 feet per second right here. All right. What about at 20 seconds? Well, that's a little harder to see, right? Let me erase a little bit so we can see a little bit better. Well, at 20 seconds, that's kind of hard to guess because it's not really moving at all. Right to the left, it's kind of flat. But to the right, it's decreasing. So you could kind of guess either way. I don't know. If I tried to guess, maybe I'd guess this is what our tangent line looks like. And we'll just try to approximate the slope of this. What's the rise over run here? Again, the run is about 5 seconds, and the rise, I don't know, what is this distance, do you think? What is this distance? Well, it's less than 50, right? Because this is 250 right here. Maybe it's a distance of 30 feet or something. So, and it's going down, so it'll be negative. Maybe it's about -6 feet per second. Okay. Could be our slope here. So t equals 10, maybe about -6 feet per second. We're going backwards or getting closer to the thing. Again, your answer could be different. This is when t is equal to 20. And the last one wants to know about at 30. All right. What do we think the slope might be over here? Well, again, just draw a little fake tangent line, or you can draw a secant line. Yeah, maybe it looks something like this. What do we think the slope of this is? Well, just pick 2 points on this line. Try to find the rise over run. The run is, again, 5 seconds. The rise is 200 feet. But it's actually falling 200 feet, right? We're going down 200 feet. It'll be about rise over run, -40 feet per second. Sorry, it's drawing off my paper a little bit. Can I do this? Hey, I did it. All right, and that's what it wants you to do for these. Again, we're going to be exploring these topics a little bit more in the future. So if this is unfamiliar with you a bit, that's fine. Just a good place to start. Let me know if you have any questions about this stuff. We can talk about it. Otherwise, best of luck and welcome to Business Calculus. Bye-bye.